Open it up for questions?
Yeah, let's go ahead and open it up for questions.
Get a lot. Yes. Oh,
Oh,
there
the
are
mics,
microphones.
the mics.
Great.
So, is this on? 20 years ago or so, California passed a law about gas stations. Do you see any of that? Do you know how well that's working?
Oh, the mic. Yeah.
Let's see, the question was about gas stations and underground storage tanks. Yeah. There are, so you're wondering about like how that's working. There were new regulations that came out in California relative to underground storage tanks for gasoline. So this is, every mom and pop station, gas stations that you have, they have underground storage tanks. And so historically, those have just leaked like crazy. So there were new regulations that came in that required much better tanks and better monitoring so that these things didn't leak as much. Fortunately, with gasoline, it biodegrades pretty readily in anaerobic environments. So we typically don't see miles-long gasoline plumes. That pretty much just doesn't happen. But there's so many of these sites, they do continue to be problematic, and benzene continues to be a problem. But with the new regulations in place, most of those gas stations have been upgraded, so we should see a lot fewer gasoline-related underground storage tank releases in the future. Question on that side? Oh. Guess we're changing mics.
Oh.
Hi, I was wondering what your thoughts were on the uses of bioremediation in holding back plumes or groundwater cleanup.
On phytoremediation?
Yes.
Yes, absolutely. That's one that I didn't get to. So phytoremediation, the term phyto means plants. P-H-Y-T-O, phytoremediation. And there's a variety of ways that phytotechnologies are used. In groundwater, we can use them a number of different ways. One of the easiest ways is simply for hydraulic control. So if you plant poplars and some other very fast-growing trees, basically at the down gradient edge of your contaminant plume, they basically suck up so much groundwater. They're basically dewatering the subsurface. And they're sucking up the contaminated groundwater, and then the plants typically metabolize it. So the plants aren't venting TCE. It's pretty much metabolized within the plant. So phytoremediation is nice aesthetically. It looks wonderful because you have a whole grove of poplar trees that are doing your remediation for you. But it is very slow, and it tends to be very seasonal. Obviously, because you're going to have more uptake of the tree, like during the springtime. During the wintertime, you're not going to get as much uptake of the water. But yeah, it's definitely a companion remedy that can go along with some of the active remedies. So we definitely support phytoremediation. It's a great technology.
I have two questions. First, I live next to the Stanford Research Park where there's a Superfund site. And I have a question that, looking at the reports which have come out, there are various treatments that are being done at various of the sections of the site. So my question is that this is about the treatment mechanisms and the treatments that would be used. Some of them are more expensive than others. So who decides which kind of treatment is going to be used in what site? The consultant is working for the responsible parties. You are the overseer. Who decides what is going to be the treatment mechanism that's going to be applied? Some places they use bioremediation. Some places they use in situ oxidation. Who decides?
Sure, I'll try that. So for this particular site, the Hewlett-Packard site and partly maybe the COE plume, part of the plume. So that is, the Hewlett-Packard site is a Superfund site, and it is overseen by the state. EPA has some very limited involvement on that site, but as far as, from my understanding, or the limited knowledge I have about that particular site is that what currently is happening is there's proposals to pilot test some of these technologies. And so what they try to do is target a very specific area to see how well that technology works. So in that work plan that might be prepared, they do submit it to the oversight regulatory agency. So in this case, it would be the Water Board for review and approval. And that ultimately is who would have to approve at least piloting that. To change So at these sites, generally, the remedy, the cleanup remedy, is pumping and treating. So to change that remedy, it actually does go through a formal process, and to do that, it would likely come through EPA. But what there would be is an evaluation or a feasibility study for these different alternatives, and then there's criteria that it goes through, what we call 9 criteria, one of which is community acceptance. So it would have to go up for public comment and so forth for there actually to be a formal change in that remedy. So as far as who ultimately decides, it does have to go through the regulatory agency. So in that case, the responsible party and the consultants actually don't get to decide.
My second question is really a comment. It's about the vapor intrusion and your community outreach. I really encourage you or the other regulatory people to do that. In the research park, Stanford Research Park, Varian is in the process of reconstructing a building over a subsurface plume. And I followed the building plans through the building department. They didn't have the vaguest idea that there was any kind of concern about vapor intrusion that they should be concerned about. It's the DTSC, by the way, that is oversight, does the oversight. And then this process then went to the Architectural Review Board, and I spoke at the Architectural Review Board of Palo Alto about the possibility in this issue, and these people were not really at all aware of the idea of vapor intrusion. So I just want to encourage you and other regulatory people to really bring this issue of vapor intrusion, which is now becoming more of a concern and becoming more aware of it, to the people who are in charge of deciding about improving the reconstruction or the construction of buildings in Superfund sites in the valley. Thank you.
Thank you. Thanks for your comment.
My question's about chlorine. I mean, all these things have chlorine in them, right? And sometimes the beasties eat this stuff, and that's supposed to be the end of it. And other times you incinerate it. I'm sorry, we don't incinerate it. They thermally destroy it. What happens to the chlorine in those two examples?
So with the thermal oxidation,
The first one being beasties eating it, and the other one being, I don't know what you'd call it.
I'm sorry, I didn't hear your first one.
Bio.
Oh, bioremediation, yeah. So with the in situ bioremediation, the chlorine stays in the ground, so it just basically becomes inorganic. Nothing really happens to it. With the incineration, so with the carbon, where we're doing pump and treat, and the TCE goes back into the carbon, and then we have to send the carbon off-site for regeneration, and we run it through a thermal oxidizer. It does get incinerated. One of our concerns with those is the production of dioxin. So we always make sure that we have the proper vapor controls in place so that we're not, putting excess amounts of dioxin into the air. So it is properly managed. Those facilities are all permitted because we don't want to affect those surrounding communities by just taking waste from one community and sending it to another community. That's not right. Is that kind of what you were looking for, or?
I still don't know where the chlorine goes.
Well, the chlorine in the subsurface, if it's bioremediation, it's just immobilized. It's just chlorine. It doesn't go anywhere. It just sits there. Yeah.
And the other ones, it just goes somewhere.
Yeah, more or less.
My question is...
Were you waiting? I'm sorry. You okay? Okay.
Starting. With regard to the contamination sites in Mountain View, in some of the areas east of 101 near Moffett, it used to be an agricultural area, and they had a lot of deep water wells that were shut down but left in the ground. Have there been any documented cases where the surface water, contaminated surface water, has gotten into those deep water wells and contaminated the deeper water?
That's a really good question. So his question is, for all the former agricultural wells in this area, is it possible that they're conduits for migration of this highly contaminated, well, not entirely highly contaminated, shallow groundwater getting into the drinking water aquifer?
Right, because Mountain View does use deep water wells for their water source in
Right.
dry periods.
Yeah, and the local water source here is mostly through Santa Clara Valley Water District. Is that
Yes.
correct? That's where most of you, okay.
Yeah.
So Santa Clara Valley Water District actually tracks this stuff very closely. They have a very comprehensive toxics management program. So they would be the ones to ask. I'm personally not familiar with those deep wells, but it's a good question because particularly those deeper historical agricultural wells, they wouldn't have had the same construction standards of wells that are installed today. Yeah. So today, wells, whether they're monitoring wells or modern drinking water wells, they're designed in such a way that you basically don't get any shallow groundwater going into those deeper aquifers. But back in the day, agricultural wells that may have been installed 80, 100 years ago, they wouldn't have had any of those seals in place around the well. And so there is a potential for downward migration. Santa Clara Valley District, they are the water supplier for this area, so they would probably be the ones to
So I could answer that question a little bit. So within the MEW area, that was certainly a concern. And so one of the things that we had to do is assess in the entire area is that very question, which is, are there irrigation wells or any wells that could serve as potential conduits, as you mentioned. And so a number of them were identified. We did work with the Santa Clara Valley Water District to help identify some more of these wells and then to seal them. As far as other areas outside of our area, I would agree with Kathy that would.
But you don't know of any documented cases where it actually did contaminate the deep water wells?
Well, a couple things is one, particularly for the MEW site, is Mountain View did have a drinking water well within a mile away that did have to be shut down just because of the potential for migration.
So it did happen, though. I mean, it did get.
Yeah, it did happen, and then what's suspected, the reason why we do have deeper contamination at the MEW site is because of these conduits that were probably from former agricultural or irrigation wells. And so that they probably did serve as conduits on why we saw deeper contamination. One of the things that we want to do is just make sure that the deeper contamination, which is what would more likely be used for drinking water, is cleaned up.
But there is no remedial solution to that problem if it gets contaminated in the deep water.
Oh, so the deeper water, we do have. Well, actually, I say did have extraction wells, deeper pumping wells to clean up the groundwater. It was certainly more localized, so we were able to pump and reduce those concentrations. The extent of the contamination, even at the MEW site, like at 250 feet, was much smaller in length. So we were able to pump to control that and reduce it.
Mm-hmm. All the drinking water wells, can I just say this, that I know of, are around 830 feet deep. They're into the really deep aquifers now. Even though there might be aqualudes or, all this stuff you can study.
There were agricultural wells.
Yeah, but those old wells, I don't know.
Right, you're right.
830.
Yeah, I mean, what the Santa Clara Valley Water District and what they could use, or Mountain View could use, is ones that aren't so deep. And the one, even I think it was Mountain View 18 that was shut down, was not, I don't know the exact depth of it, but it wasn't that deep. I mean, in comparison to, as you're, that are like 800s, right?
Over 800.
Right, thank you.
So you had a question over here?
Yes, my name is Brian Schmidt, and I'm one of the directors of Santa Clara Valley Water District.
Ooh.
Well, there you go.
Although I am relatively new, so I don't know some of these older issues, but there are requirements when wells are shut down to be adequately sealed. Maybe some of these wells from the old irrigation and orchards might precede our permit requirements, so there might be issues from those. And usually you draw deeply, but not necessarily 800 feet. You can definitely draw from a shallower area than that. And then Mountain View owns its wells. While we have permitting authority, those are Mountain View's wells. So if the gentleman who had this question wants to talk to me afterwards, I can try and get you connected to staff who know much more than I do. So just on that issue. And I had 2 questions of my own, actually. First of all, any ecological impacts, particularly in the Moffett area? And are you testing for ecological impacts? And secondly, we have contaminants in our groundwater that aren't Superfund contaminants. Nitrates are a big problem in our area, perchlorates to some extent, and we're looking at chromium-6, particularly South San Jose. And any of these advanced treatments or new treatment systems you're working on for Superfund contaminants, are they potentially useful for addressing those issues?
Okay, so I'll try to answer the first question regarding Moffett Field in particular. So while there are some impacts, there are some ecological impacts from other sites at Moffett Field, but not from the groundwater contamination that we're specifically referring to. So we have looked at this sort of like groundwater to surface water impacts, or whether there's any. So for this particular site, as far as this regional groundwater contamination, we haven't identified any. But there are other ecological impacts at Moffett Field for from other types of contamination. The second question regarding
The nitrates and perchlorate.
yeah, perchlorate. So we haven't identified. So is perchlorate at other sites, certainly in the South Bay, and I'm sure you're aware.
Yeah, with the nitrates, the nitrates wouldn't specifically be related to the historical hazardous waste issue, but nitrates in shallow groundwater are certainly a problem in many areas. But they are usually confined to shallow groundwater for the most part. They're not going to be in the deeper wells. That's more of a shallow problem, and it's definitely related to historical agricultural practices. It's related to all the leaking sewer pipelines. You know, there's lots of nitrates in shallow groundwater, so that's well understood. It is kind of outside the scope of the TCE contamination, and it's going to behave a little bit differently in the subsurface than TCE would. And then perchlorate, what was your specific question about perchlorate?
Well, in both cases, it's not so much, I understand they're not from
Right.
the same sources, but to your treatment methods, are they possibly applicable?
Oh,
to
yeah,
these
they're
other
not,
sources?
no.
Yeah,
So
no,
we wouldn't
right.
we would not use, we wouldn't really use pump and treat. We would not use air stripping for nitrates or perchlorate. Perchlorate, I think currently what they're using, I'm not actually working on any perchlorate sites right now, but I think they're mostly using resin reactors. So basically, perchlorate is a salt, so it basically sorbs onto the resin. And I think that's typically what's being used these days, but it would be different than the typical technologies that are being used here. And was that it, or you got other?
Well, and chromium-6.
Oh,
That's
Chrome 6, we have a
brand
Chrome
new.
6 expert here, a PhD student at Stanford. So what's the latest? Yeah.
The most popular one for treating it in situ is trying to reduce it by bioconversion. I don't know how well it works though.
Okay. Yeah.
The longevity of that remediation is very well understood.
We have a natural problem. This is not a contamination. So I'm not sure if that'll work.
I think it would be treating it before it's distributed. Then.
Okay, thank you.
There you go.
Thank you.
Are we here or there? Okay.
That way.
I'd like to explore the policy area of cost effectiveness. Do you apply cost effectiveness criteria? Are you able to do radical things like suggest be left in a certain area, but medical costs be covered for the people who were exposed? Things of that sort.
It's one of the 9 criteria. Did you want to talk about that?
Sure. When I was mentioning how we evaluate and compare cleanup alternatives or remedy, cost effectiveness is one of them, but one of the thresholds that you have to meet is protection of human health and the environment. So it wouldn't be if we needed to do something to protect human health and the environment, then we would have to do that and then look at the alternatives that can meet that criteria. So we wouldn't weigh cost versus health. But assuming that the treatment alternatives can meet that threshold, which is protection of human health and the environment, then one of the criteria is cost effectiveness. Others are just short-term and long-term effectiveness, implementability, and then also, as I mentioned, community acceptance as well as state acceptance.
So
Cost effectiveness is just one of the 9 criteria.
I think I heard you say that essentially you'd spend an infinite amount of money for human health, that's an absolute requirement?
What we would do is we would ensure that we're protecting human health, and we have thresholds on the ability to do that. So for example, the cleaning up the groundwater as far as protection of human health. Currently, we're not drinking the groundwater, so what we put in is controls to ensure that no one drinks the water, no one puts a well in to drink that water, and things like that. So those are some of the measures that we can take in the short term while we're in the long term trying to clean up the groundwater, which will take decades. But in the meantime, we would protect human health by ensuring that no one's exposed to drinking that water. As far as vapor intrusion, which is a different exposure pathway that we're evaluating now, is again, that would be something as evaluating is from this contaminated groundwater is there exposure to people that may be in buildings, and are those levels at a high enough level of concern such that we need to mitigate it or reduce the concentrations.
Thank you.
But one comment on the vapor intrusion, as Kathy mentioned too, is the cost for cleaning up the groundwater, if we were to, in comparison, is a very high cost. I mean, even just pumping groundwater is very costly. Implementing some of these alternative technologies, they are expensive, particularly as the area that you're trying to clean up is bigger. As far as mitigating for vapor intrusion, on a scale-wise, if we're looking at scale, it's at a much less cost. I mean, we can implement very effective, cost-effective mitigation measures to address vapor intrusion. So that is the good news.
So do you know how many cancers, birth defects are caused with current land use? And then you have to put a price on that, and then you calculate how expensive it would be to prevent those, or are you flying completely blind? So how many cancers from that plume that you showed, for example? If you would do nothing, or if you do what you do, and then the cost effectiveness.
Well, we don't measure. I mean,
So you're flying blind, basically.
Yeah, I mean, we don't measure. Our way of measuring isn't that, but we do evaluate when we're looking at alternatives. What does it mean if we don't do anything?
So what are the numbers? How many
Well,
cancers if you don't do anything?
Well, what
I mean,
we're
you
looking
have
at
to
is
know this, right? Because otherwise, why spend the money?
Yeah, we don't collect. We don't know that information.
So it's unknown. Okay.
That would be unknown.
Yeah, and unfortunately, you can't
That's
tie
scary.
a specific health issue to a specific site. The
So why
epidemiological
you do
information, for the
something
most
about
part,
it
just
then?
isn't
So
available.
what prompts you to do something then? If you can tie it, is it just a feeling it's toxic and you don't know?
Can't
Or?
wait for the answer, you should sit down.
Yeah.
Yes?
There's no answers. They're waving their hands, basically.
Even if the risk assessments would have addressed this gentleman's question, I mean, before you implement the remedy, there is a risk assessment for human health that drives the selection to some degree, right? So it's not necessarily telling you the number of the cases, but it tells you the risk of the site from a human health perspective.
Yeah. What this person's referring to is that what we do is we assess. So at our sites, we have contamination. We assess the potential risk of exposure to that contamination, and we look at these various pathways: drinking it, of inhaling it, and as part of our evaluation is really at what level can people be exposed to, and what levels do we have at our sites, and that's how we set up our cleanup levels or our action levels. So what EPA is required to do is have a basis for taking a response. So what we have to be able to demonstrate is that there is the potential that we have potentially a completed pathway, exposure pathway, where people can be exposed, and then what the remedy would be to fix that, to remedy that situation. And then we look at that across the site. That's essentially what it doesn't do, though, is specifically answer the question you have, but we do assess human health risks, And if it's the case, in other cases, ecological risk. But for the information that we're looking at, we are looking at the potential human health risk.
So I have a question about the vapor intrusion and how you're determining where you are looking for it. If you're just looking for it at the Superfund sites, or are you looking for it elsewhere? And if somebody has a concern, what they can do.
So we're certainly looking at it at all our Superfund sites with contamination, and that's in our corrective action sites that Kathy also works on. But at some of the other sites, and there's a lot of sites that are, the lead is the local agency or the state agency where there is contamination. That is where, if it's not a Superfund site or EPA is not involved, then it would be going to that local agency who oversees, the contamination. And so one of the things we are trying to raise awareness is just the potential by having shallow groundwater contamination in this area. And again, it depends what the chemical is and how high that concentration is. But you would have to go to, or at least first talk to the local agency that oversees that work. If it is a Superfund site, then sure, you can certainly contact EPA.
So we got here because of historic sloppy manufacturing and process usage techniques, which presumably were corrected quite number of years ago. And what's the rate of newly discovered toxic sites, say in Santa Clara County or in the nation? You found any more lately?
I don't know off the top of my head, but there's only, like in our region, 1 or 2 sites a year that is added on as a Superfund site. So there's been a couple sites that were added last year in Los Angeles. There's mining sites that are certainly right. So that's a different type of contamination. But the 2 in particular in Southern California were ground, contamination like this stuff. In this area, I'm not aware of any. What we have is the state of California, and so it's the Regional Water Quality Control Board. They have sites that it could be state sites, and if they're overseeing it, typically it does not come to EPA if they're overseeing that effort.
So if we wait long enough, this will all go away.
Yeah, you're gonna have to wait a long time.
Yeah.
Sometimes new sites are discovered, and particularly with groundwater sites, you discover it because contamination comes into your upgradient well. So with all these sites, we have wells that are down gradient where the direction that the groundwater is flowing, but we also have sites that are up gradient because we want to see what's coming onto the site. And so you're monitoring that over a period of years, and all of a sudden you start seeing TCE coming into your upgradient well, and so then you have to chase it up gradient. And so, new sites do come on board, but like Alana said, most of those are smaller sites that are under state authority, so we don't have direct contact with some of those. But as far as the Superfund sites, we're not listing very many at all.
So we've kind of cleaned up our act.
Hopefully we have, yes. It's been many decades now, but that was the whole point of the RCRA program, the cradle to grave management. And here in this area, obviously we're not doing as much manufacturing anymore, and so, sort of new sources of contamination are just not there anymore. Oh, yes. Oh.
Yeah. Could you comment on the status of the abandoned Mercury mines up in the hills? Do they represent a hazard down here in the valley floor?
Oh, abandoned Mercury mines? Do you want to talk about that or me?
Go ahead.
Okay. We have, no, there's actually a bunch of abandoned mercury mines in California. Probably one of the ones that's been most notorious is up in Clear Lake, the Sulphur Bank Mercury mine. So mercury is common in the Coast Ranges. There's a couple of other ones. New Idria, was that just listed? Mm-hmm. That was one of the new ones that was just listed. So that's another mercury mine that's down south of San Jose, way south of San Jose. And there's a few others. But mercury is very challenging to clean up. So the Sulphur Bank site, most of that was problems with mercury getting into the lake, and then just the tailings, the abandoned mine tailings washing into the lake. So they did a huge effort probably 15, 20 years ago where they basically did some reconfiguration of the slopes to make them less erodible and then they landscaped them. They did what we call hydroseeding to basically maintain the soil in its current condition so that it wasn't washing into the lake. Beyond that, groundwater with mercury is not that much of a problem. It's more getting into the water systems, getting into the aquatic biota, and then getting up to the food chain. Getting into methyl mercury, organic mercury, is really problematic. That's what we're looking at, getting into the fish and things like that. So the Mercury mine sites, we continue to do work on those. They're completely different than these large groundwater sites, but we continue to have a path forward on that. And a lot of times it's just going to be reconfiguration of the mine tailings, because many of these Mercury mine sites are really, really big. And so they take a lot of work. But they're also ones that we have quite a bit of experience at, so we're moving forward on those. Were those the specific ones you were thinking of, Clear Lake? Okay, great, thank you.
We'll have to go to close there. Thank Kathy.
Thank you. With our flash drive.